Everyone, alright, let's do this. It's April 12th. Maximum rectangle. In a row column binary matrix with 0, 1, find the largest rectangle containing only ones and returning its area. I don't remember how this one is done though. I think some very sick algorithm. Like some prefix sum, like two levels. Or like for each one, for each row, right? So we say the largest ending? No. The maximum consecutive ones. Okay, the maximum consecutive ones, or the columns. And then when you go to the next one, if the previous, you pick the minimum of the two. Yeah, I have a vague memory of the algorithm, but I don't quite remember. It should be some type of DP, right? Like the maximum ending at some cell. Right? The maximum ending at this cell will be 1, 1, with 0. So maximum ending at this cell will be, we'll check the maximum ending here, because it's gonna be whatever this is. And we try to see if we can fit here into this. And if it doesn't have, then we look up. 0 is nothing, so here, whatever ending in here, so this is 0, so this is nothing here. So now I shall look up, right? The maximum, so maximum ending at this. Not really maximum ending at this. It's actually the, it's just height. So we 2. Okay, so maximum ending on this. I look in here, and it has a height of 2. Right? It has a height of 2. I don't think that's the one. I remember the algorithm is very smart. Some prefix sum, right? I don't remember. Ugh. Yeah, it's DPO stack, monotonic stack. Let's try monotonic stack. What? Monotonic stack. Ooh, monotonic stack. Are we saying that in a line, right, we're doing this? So we have 1, 1. Actually, no, this is 3. 1. This is 3. And I have 2. I have 2. Right? This is what this is. I have 3, 1, 3, 2, 2. Now, the question is, what is the maximum rectangle we can get out of this? So yesterday's problem is to find maximum on this, not maximum on the total on this. Today is to find the maximum on this. So we have this, now this comes in, right? So maximum so far, so this is 3, right? And this comes in, the maximum so far is going to be maybe it's the increasing, monotonic increasing, or it's still decreasing. I mean, you should pop something that's bigger than you, right? So it's increasing. If something bigger than you and you pop, then they must contain the same height. Like they will contain your height, right? They will contain your height. So which means we start with 3. This comes in, right? And then I'll pop this. So it becomes 1. But as I pop, I pick smaller. So ending at here, the largest is 2. Right now it's 1. And then we do 3. So we don't do anything. Right? So 1, 3. Now 2 comes in. And then 2 comes here, I'll pop this. So it become 1 and 2. But because I popped this, it'll add this length. So that will be 4. Right? And then we have a 2 comes in. We'll pop the same. So I'll pop this. But you pop this. And this comes in. Well, because it's monotonic increasing, right? What it means is in between these two, in between the two, everything is larger than you. So when this one comes in, I'll pop this, then I stop here. So in between these two, that's 3. So 3 times 2, this is going to be 6. That's the current round, right? Right, so we're done. We move on to the next one. So next one we have 4, right? 4, and this becomes 0, so it becomes 0, and this is a 0, and this keep going on as 3 and then 0. So we say we have a 4, then 0 will pop this, but because it's 0, so it's still 0. 0 is still 0, and then 3, nothing, right? So it's just 3, and because it doesn't pop, and then 0 will pop 3, so it's still a 0. So that's what we for 3. Yes, I think that is a solution. That is a solution. It's the, I guess that counts as hint, right? It's monotonic. It's monotonic increasing array, and we'll keep the height. We'll keep the height, right, at each position, and because it's increasing array, if we find something that's bigger than me, that will pop it. So we'll keep pop, because every time we pop, you know that this thing contains, because this thing is higher than me, because I want to know the maximum square rectangle that ends in the current one, right? The current height that ends in it. So I can pop until I hit something that cannot pop. And because it's monotonic increasing, then everything in between, so this is this and this is this, then everything in between is larger or equal to this thing. So they can all form the same rectangle that's have this height. And now I just need to know the difference between these two, right? The height difference between these two. Not height difference, the indices between these two. Then I can compute the rectangle that ending in this and has the same height as this. And then, yeah, basically we just go through the whole thing and then do it. And then we do it row by row, right? Row by row. So O(n) squared. Okay. Yeah, I recall it. This is the memory kind of came back to me. Oh, I remember struggle a lot on this problem before, like really a lot. But I also done this many times. I think this probably also 4 times at least. Okay, so what are you going to do? What I'm going to do is, oh man, it's a character. Ugh, that's okay. I need a. I need something. So at each row, I need a monotonic stack. So I will do a stack at each row. And at each row, I need to produce, I think it's the overall, but let's do this first. N, now M equal to matrix dot length, and N equal to matrix 0. Okay, does it have a 0? Yes. 0 dot length. Okay. Then we say int height. New int n, right? Rest equal to 0, right? So it's and then we'll go through the first, right? We'll go through the first. You can say for int I, 0i smaller than m, because we'll go through every row, I plus plus. Okay. And then we'll do a stack, right? We'll do a stack. We'll say stack integer stack equal to new stack. Then for int j is 0, j smaller than n, j plus plus, right? So for each one, I'll say heights j shall equal to depends on matrix I j. Is it equal to 0? If it's equal to 0, then it's a 0. Otherwise, it will be heights j, whatever it is before, plus 1. Right? That's the current height. And then what I'm going to do is while stack is not empty, Okay, and heights j is smaller or equal to stack.peak, right? If that is the case, then we are going to pop it. Actually, that's not true because we're not storing, we'll store the heights in it. Okay, we'll store the heights in it. Then basically we're just gonna say stack.pop, right? Which is pop, 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 pop until we cannot pop, right? Until we cannot pop. Then what? Then what we're gonna say is if stack.is empty, so nothing is on the stack, then what we're gonna say is res shall equal to math.maximum res and heights j, right? Else, if we have stack, then res shall equal to math.maximum res, and here is gonna be heights j times the difference, the j, right, minus j minus stack.peak, right, 0, 1, 2, 3. Yeah, let's have 3. Yes, will be like this. Okay, once we calculate everything, we're gonna say stack dot add, or add j, right? So we go through everything, and then each one we do the monotonic thing, and then once we're done, we move on to the next one. Maybe it'll be easier. Let's say we do this one outside, right? We do this outside, and each time we say stack.clear. So we clear everything, and then we start, right? So we don't have to constantly creating new stack. Now, one more thing is the heights. Is the heights correct if we do it this way? So if it's 0, basically reset, right? Reset everything. Yeah, I think it's looking good. And at the end, well, we have a syntax error, and at the end we'll just return res. Okay, let's give this a shot and see if we have it. We happy? Yeah, we happy. Yes, I think we will be happy. Let me write something here. $85. This is very classic, right? It's classic hard problem that I think I have solved at least 4 times. However, this time I still needed a little hint, right? A little hint. We use monotonic decreasing. No, it's increasing. Increasing array. For each row. With regards to the height at each position. When a height pops, right, pops the top of the stack, it is guaranteed that the pop value has higher height, right? Bigger height than the current. Thus, we can always include, right? We can always extend the rectangle ending at the current height. Okay, let's give this a shot. And hopefully we'll get this done once. Honestly, it's actually not. It's only 2 times. I thought it was 4 times, only 2 times. But I got the first one wrong. Alright, that is not expected. Okay, what did we do wrong? So height j is no, so height j is 1. Stack is empty, so we're going 1, so stack, I put 1 in it, right? And then I do, oh, when you pop everything. Oh, when you pop everything, that was wrong. When you pop everything, Interesting. When you pop everything, so every time you pop, and maybe we shall put something at the start, you know? Maybe we shall put a, I don't know, a -1 at the start. Stack dot add -1. What do you think? We kind of have a stop at the beginning. Huh. That ain't right. Oh, I can do this. While stack dot peak is not equal to -1. What's this? Yeah. Then if you're 0, you do 1. If yeah, let's see if this one get it right. Yep. No. So it's multiple times. I thought it's 4 times, but actually it's not. All right, let's give this a shot again. Nope. Okay, it requires a little bit more thought into this. I thought it was good enough. Okay, what we have? We have 0, 0, 1. 0, 0, 1, no, 1, 1, 1. Yes, I did not consider that. So which means we just, keep its monotonic array. Yeah, so at the end we have the monotonic array, then you need to find the whole thing. Okay, so yeah, I know. And don't forget for and then don't forget to also check the rectangle formed by the monotonic array stack itself, right? But so everybody in it is larger than this, right? So I just need to pick the smallest, right? We'll pick the smallest, and actually this is actually not right. If stack dot is empty, actually no, right? It's not dot empty. If stack dot peak, right? Dot peak. Well, in this case, do we even need to do this? Yeah, we don't even need to do this because I always have something in the stack, right? So we can just do this. We can get the result out, blah blah blah, and then at the end, well, we shall say if stack dot, I think its size, right, is larger than 1, then we can say res equal to math.maximum of what? Of, you know, the start, which is stack, which is a height, res height stack dot. Ooh, how do I get to the second position in the stack? That is a good question. I actually don't know. Stack, can we get? We probably shouldn't use a stack. Or I actually don't know. Does stack have? Hold on, let me when technically you can't do that on a stack. But I guess we can try. Can we have stack dot get? Oh yeah, we can. Nice. So get 1, right? So this is the height, and times the length shall be what's the length? The length. Shall be stack dot peak, right? It's at the bottom, minus stack dot get 1, right? Plus 1. Okay, let's try this. La tercera es la venganza. No. Tercera es la... heights. No hay quinto malo. No hay quinto malo. Ooh, that is not right. I still get... that's interesting. How? How I didn't get to 3? I don't understand. This should be 1. This should be 0, 1, 2. This should be 0. Right? Let me think. Can we do something like this? So that was the last one. Minus 1, 1, and 2. Oh, because, oh, I forgot. Because this one popped this one. Dirt. Dirt. That is a dirt. Okay. Okay. So whenever it encounters a 0, whenever I encounter a 0, oh, I mean, let me think. Let me think about this. So we check the first one, because if it's a 0, it will always be there, right? It will always be there. So it depends. Like if it's not a 0, then we shall, like the first, the second position on the stack, if its value, if its height is a 0, then we don't take that because it doesn't extend from there. We should go on the next one. But if it is not a 0, that means it must go all the way to the left. That makes sense, right? So we can say, well, it will always be larger than 1. This is guaranteed, right? This is guaranteed. So what I need to do is the position. I'm going to say index, int index shall equal to 1. We see heights stack dot get 1, right? If this is 0, then index shall equal to 2, right? Index shall equal to 2. Otherwise, index shall equal to 1. Then we say if index is smaller than n, then shall equal to, this is basically index times peak minus index. All right, how about this? Will this one be right? Still not right. That doesn't make any sense. Index is equal to 0, we got 2, but otherwise index will be 1. Like what do you want to what do you want to achieve? No, it's not 1. Right? Hold on. What are you doing here? What are you doing? I'm trying to find out if we can extend all the way down, right? If after monotonic array, then the first one is not a 0, that means they go all the way down to the start, right? All the way down to the start. Yes. So if it's not equal to 0, they go all the way down to the start. So start, I see a 0. If it is 0, then the start has to be this plus 1, right? Has to be this plus 1. Now we have a start. Now we say start is smaller than this. That would be height of the start. Right? The height of start? That's not true. That's not true. It should be still height of this. This is always true. But what if it's equal to 0? Damn it. Ah. So the start. If the height is equal, if the start is, if the front of the stack is a 0, right? Then the height should be the next one. Okay, so there are two things. Okay, there are two things. So, okay, we'll do this. We have int start and int min h of two things. We say if heights stack dot get 1, if that equal to 0, right? So the first on it's a 0, then we say start shall equal to stack dot get 1 plus 1, and min height shall equal to, well, it depends on whether it has another one, right? Damn. Okay, how about this? If stack dot peak, right? If heights stack dot peak is larger than 0, right? If that's the case, then we do this. Otherwise, there's no point. Otherwise, there's no point. If the final is 0, then everybody is 0. Yeah, there's no point. But if it's larger than 0, then we can try a start and a min height. And if the start is this, is equal to 0, then we definitely have another one. So min height should be heights stack dot get 1, get 2, right? That will be a min height, right? That will be a min height. Else if it's larger than 0, right? Which means the first one is larger than 0, and everybody in front of it will be larger than this. So that is the, so the start in this case shall be equal to 0, and the min height is equal to heights stack dot get 1, right? And then we can say res shall equal to math dot maximum res min height times stack dot peak minus start plus 1. This one, right? Okay, I don't remember doing this last time, so it's possible that, yeah, I don't remember doing this method before, so I don't think so. All right, what is this? Okay, we have 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, and then 1, 1, 1, 1. Okay, so in this case, shall be 9. I only get 8. 1, 2, 3, 4, 5, 6, 7. How? So all the way to here is 0, 0, 4, 1. 0, 1, 5, 2. So in this case 1 is going to be pop. Pop this, so it will be on 2. In this case, 2 would pop. And after 2 pop, it look great. After 2 pop, this will become 4. And then I can also have from 1 to the end, that will be 3. So right now it's actually 5, right? At the moment it's 5. So the next is 0, 2, 6, 3. So 3 will pop this. That will give you 6. Right? That will give you 6. And at the end, we have 2 and 3. So that will give you 2 times. Now we become 6. And at the end, we have 1, 3, 7, 4. 4 will pop this, coming here, right? So oh, I only did 1. Shoot, I should do every single one of them. I see. Okay. Alright, so what you mean is... Damn it. Oh, I don't have to consider because I already consider when you pop. Right, when you pop, I already consider that. So I just need to consider starting from that position going down. So basically, we just start from the stack. Right, we start from the stack, the first position of stack, and then go all the way down. And the second one, go all the way down. Third one, go all the way down. Because towards the left, we already considered. Right? You go to the left, you already considered. And hold on. So if there's something, I go to the left, right? And then... Okay. I need to consider the entire thing, right? I need to consider the entire thing, because I only consider the left side. Everything as I consider the left, I never consider the right. I never consider the right. I consider the left. Okay. So at the end, right, at the end, what I need to do is consider the whole thing, right? Because everything in between, everything is larger, right? So everything start from whatever I have. I look to my immediate left because I know everything in between is larger than me, right? So basically we start from the first one. Yeah, this is not right. I have to redo this one. Hold a second. All right, let's finish this up. So basically, we're gonna say for ij in k equal to 1, k is smaller than stack dot size and k plus plus. All right, and for each one, we find we know the height. Then we just need to know the width. So the width shall be, the height is this, stack.get k, right? This is the height, times the width shall be stack.peak, that's the last one, right? Minus stack.get k minus 1, right? but not including this. So 0, 1, 2, 3. So 3 minus this. Yeah. That is that. And then we say res shall equal to math.maximum. Res and this. Is this right? Correct for this. Let's check this. Yep. Come on. Took 4 shots. Wow, 5 shots. This one's still not right. Holy crap. My. Okay, let's take a look what happened here. We have 0, 1, 1, 0, 1. 1, 1, 0, 1, 0. 0, 1, 1, 1, 0. 1, 1, 1, 1, 0. What else? 1, 1, 1, 1, 1. 0, 0, 0, 0, 0. I can see the 9. Well, okay, this one I get a 6. This one don't get anything, and this one I get whatever. Oh yeah, the 9 is missing. Holy crap. Huh? Is this not right? Right, so basically the question is if we have 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, and 1. Or what you're saying is maybe we should just pop one more time. You know? Because every time when you pop, we can actually argue that every time when you pop, right? Every time when you pop, you count how many times you popped, right? You count how many times you pop. Then all of those. Ugh. Yeah, because the 1, it popped everything. So when you pop, you do that when you pop. You do that when you pop. You do that when you pop. So each time you pop, right, you can also compute. Okay. So you mean every time I pop, I have something. Hold on. So every time I pop, I have this. Every time I pop, I have this. Every time I pop, have this until I cannot pop anymore. So those are starting from this, right? We get that. Starting from. Because variable to the left is smaller than me, so I cannot start from there. So when a height pops the top of the stack, towards the right, it is guaranteed that all the heights between the popped and the current is higher than the popped and the current. So we can compute the rectangle formed with the popped as its left side, right? Because everything towards its left is smaller. But no, but because when this gets popped, I compute that. Oh, you do it 2 times. You look left and you look right. Right, and yeah, for the popped one. Yeah, on a height when the top of the stack gets popped, it is guaranteed that all the heights between it and the current are higher, and all the heights between it and the new top of stack are also higher. These can form a rectangle with the popped as its height. Alright, this one I need to do it on the other side. So this is also fine. I wonder if we need to add Yeah, I think we do. And then we do this plus 1. And we push a 0 at the end, so we can pop everybody. So height j equal to, but j is equal to 0, right? Okay, so j equal to n, or okay. And then while the peak is not equal to 1 and the height j is smaller equal to peak, now here is the magic happens. Okay, so we can say int h equal to stack. Oh, actually it's fine, right? It should be heights stack dot pop, right? This is the height. And then what we can do is the current j and this. We say res here will be equal to math.maximum res h. Oh, we actually probably don't need don't even need this, right? We can just do this times j, right, minus stack dot peak. Right? Yeah. Let's try this. New idea. No. Oh. Because they didn't add this thing to the stack. Just forgot. Oh. All right. Probably should be -1, right? I think. Yep. Try this one. The 5th shot. No, el quinto malo. Finally. My goodness. That took a long effort. Jesus. All right. Yeah, it's about the same. This one is so fast. 66 out of 74, that's why. What was the Python solution before? Did I solve it by myself? I'll be very unhappy if I solve it by myself. Oh, I think I did solve it by myself. Named tuple element. I have no idea what I did there. Okay, this is not working. Jesus. Yeah, but I think that's the same idea. That's what I have now. HT should be THE. And a rectangle with max area over a histogram. Yeah, that is the one. That's the same as this one. So, struggled. Definitely struggled. But at the end, did come up with this. I mean, I had a little bit hint, right? A little bit hint that this is a monotonic. But after that, it's all on me. And I have to went through 2 different versions, right? 4 different implementations, and neither of them work. And finally, I realized every time you pop, you can go left and right. Yeah, see that is the genius part. Every time you pop, because it's monotonic increasing, every time you pop, then if you look to the left, everybody will be bigger than me until the other element in the stack. And you look to the right, everybody will be bigger than me until the current one that's popping me. So everybody should share the same height, and we can do it that way, right? We can do it that way. And I think this is actually the simplest implementation I have among all the solutions. So, yeah, I think it's positive. Definitely positive. All right. That will be it. It's more than 1 hour spent on this. Yeah, this is one of those hard problems. And we still have this trapping rainwater. I need to go through the other solution, which is 2 pointers. But we'll do this some other time. All right, that'll be it for today. I'll see you guys tomorrow. Adios.